All right. Hey, welcome. I'm pretty excited about the stream today. So thank you everybody who is joining us. We're going to be doing something a little bit different, I think. I think what we're going to be doing is talking more about the developer workflow and the developer workflow with respect to service mesh. Service mesh, hey, big buzzword. Not really. Really useful tool. So I hope over the series of videos, Christian and I are going to be able to do that. And on that, Christian, how you doing, buddy?
I am doing very well. I too am excited to share what we've been working on. This derives from some of the work that we did at KubeCon, and if I remember correctly, this was a workshop, right? This was a hands-on workshop, and I think we were expecting maybe 30 to 40 people. Oh, there goes your dog. We were expecting about 30 to 40 people, and I think we got close to 900 people sign up. So we felt that this hit a chord, at least among the KubeCon attendees, and we thought we'd bring that content to the masses in little incremental chunks, and we'll be doing this over the next 4 weeks or so. So every week we'll try to do an installment like this.
And the nice thing about doing it this way is we're doing distributed Wi-Fi DDoSing as well, where we're not just going to DDoS the Wi-Fi in a single location.
That can be a struggle when you have a room packed full of people on conference Wi-Fi. Absolutely, that can be kind of difficult to get through.
So maybe I always make an assumption that everybody knows who I am and everybody knows who you are because I know who I am, and I'm
still figuring out who I am.
But I'm just really terrible at introductions, but I should probably. I'm going to let you introduce yourself because Christian Poster, everybody should know who you are, but maybe they don't. So why don't you give us a quick 101?
Sure. I'm Christian Posta. I work at a startup called Solo.io. I have my background in building and supporting large distributed systems. I've worked at big enterprises, so I have empathy for the pain that developers and operations folks might have working in a large organization that may be slow, full of regulations, outdated technology potentially, and so on. And I've been involved in open source for the last 10 plus years or so.
Nice. And I'm Nick Jackson. I work here at HashiCorp. Well, I'm here at HashiCorp. If you're watching on the HashiCorp YouTube stream, if you're watching on the Solo stream, then I'm Nick Jackson and I work for HashiCorp. I'm a developer advocate. My background is pretty similar. I've been working in software for over 20 years, software architecture and software engineering, building distributed systems. That's kind of my thing. So I'm really excited about this content, dude. I'm like, I wish I knew this stuff a long time ago. So should we begin?
I wish we had this stuff a long time ago. Yeah. Yeah. Let's jump right in. Let's get going.
Alrighty. Straight over to the code window because we are going to do these things predominantly. We want to do these as sort of technical demo driven talks. We do have some slides if we need them, but hopefully we can avoid slideware.
Yeah, that's right. That's right. I think as we were discussing a little bit earlier that we've been in this community and in this ecosystem for a while now, a few years. But the ideas of the service mesh aren't exactly new, but the implementation is. I think the infrastructure around it is and is still evolving. And so it might be worth, we give maybe just take a couple minutes to set the context of, first of all, what is a service mesh? Is it valuable? But then also bringing it to like the the focus of this discussion, which is around why developers might care about this. So I think the service mesh has evolved over the last 3 years. So I'll give my take, right? So the service mesh has evolved over the last 3 years. I think in previous generations of microservices architectures, like think Netflix or Twitter or those, we saw that as you break a system down into constituent services and components that will need to interact with each other to accomplish some business goal, we see that having to communicate over the network causes new challenges. Or maybe not new, but they become more exacerbated because of this architecture.
Yeah,
Things like, yeah, go ahead.
I was going to say, I mean, I think the one of the things that I found really interesting was a paper by Microsoft, which was looking at gray failures in cloud-based systems, because they themselves were kind of finding that this problem, that the network just is not as stable as a cable between 2 points anymore.
Right.
Or maybe.
Right, exactly. And then when you throw in the fact that we are using or going toward cloud infrastructure, and what I mean by that is compute and network and storage and so on, that could be coming and going, like it could be failing, is likely failing. That you have to design your applications in such a way that you assume there's going to be failure, right? So in the past, I felt like we were building our applications in the nice comforts of our enterprise data centers, where we said those failures will never happen, or they're so unlikely that we're not gonna worry about. Like the database will never go down, right? Our other services will never go down. We're going to build them redundantly and highly available and so on, that these things will never happen. But in a cloud environment, you kind of have to shift the way you build your applications. And when you're communicating over the network, especially these cloud networks, you have to assume, what happens when this thing does go down? We have to be responsible building applications from a developer's perspective. We have to solve for that.
So I want to ask you a question. And the question that I want to ask you is, but why are we building applications in this way? Like, is this just some crazy desire of a software architect that want to make our lives as developers really, really complicated? Or is there a real sort of tangible benefit?
Right. So that's an awesome question, because, I think you phrased it right, because it is complicated. If we take the monolith to microservice migration that we see a lot, I meet with a lot of customers, people in the community, prospects for Solo and so on, they're undertaking this journey. Now, is it worth it? So at the end of the day, the whole point of a microservices architecture is to realign your technology and your people to be able to go faster, to be able to make changes to the system independently from other parts, to be able to get things out quicker to production, right? Because nobody knows exactly what's going to happen, right? So Microsoft, as another paper that Microsoft wrote, showing of all of the good ideas that they had, I think they were evaluating Visual Studio or MSDN or something, of all the good ideas that people have and wanted to implement in the product. Not the bad ideas, right? The good ones that, the business came and said, let's do this, and, we'll have X revenue, right? They put all the fancy PowerPoint slides, right? But then they found that 33%, so about a third of those good ideas actually had the intended positive effect they wanted. Another third had zero impact. The other third had a negative impact. So the point of that is, even though the business folks, whomever is building requirements and project plans and all this stuff, have really good ideas about how to improve the business, you don't actually know until you put it out into production and see customers touching it and how they respond, right? So the faster that you can come up with ideas, shoot them down and move through them, the better, right? Because then you'll find out what really works and get rid of the stuff that doesn't work. Avoid that. So a services architecture allows you to realign your organization to be able to do that better. But that's not for everyone also. I got to point that out. Yeah. This is my opinion. Love to have you. I would love to hear what you think. But first of all, building things as modules and components, that is foundational, right? Now, when it comes to microservices and deploying them as components and service independently, I think that makes a lot more sense when your organization and your operational structure around those services, you get benefit from doing that. So, and let me give you an example. So in the Istio community, so this is a counter example really. In the Istio community right now, what we're seeing is the control plane for Istio, which was built as a handful of different microservices in a services style architecture. What they found was when people take Istio and deploy it, that the operators don't really change the services independently from each other, that they aren't spread out across multiple different teams or different parts of the organization to operate the control plane. It's usually one team that's doing it, or even one person, really. And so what Istio is doing is actually taking those and putting them back into a more monolithic deployment. But the components are still there, right, underlying, right? The modules are still there. That's still the right way to build good software. Now, your deployment and which one you split out for, which one becomes a service and independently and so on, that just depends on the makeup of what is really slowing you down. If the organization and the people are not, and the bottleneck isn't that architecture, then don't optimize for microservices, right? Then a monolith will help you go faster in that case. But if it is, then a services architecture would be potentially appropriate.
But I guess, and I hope everybody can hear me now. I might have toggled the mute the wrong way before. Sorry. But I guess, like, even still, some of the techniques that we're going to show, I mean, like Canary deployment, whether you're deploying a monolith or a microservice, there's validity in Canary deployment. Being able to sort of debug your applications and services and connect them to your cloud-based environments. I guess there's validity in there as well. So I'm hoping that there is something for everybody, and you're all going to really enjoy.
And that's what I'm pretty excited about, is that since we're looking at this from the developer's perspective, this is stuff that will advantage the developer regardless of what operational architecture you have. And right, so we can dig right in. We're going to be talking about things like a service mesh, right? We'll talk about HashiCorp Consul service mesh. We'll be talking about things like Canary releases. We'll talk about things like tracing, distributed tracing. We'll talk about something that we've been able to do and always need to be able to do as a developer, which is debug your applications and debug your services. But especially if you go to a services architecture, that becomes a lot harder, right? So what are some of the tools to help us do that? What are some of the components like service mesh, like potentially gateways, API gateways that can help assist developers to go back to being comfortable with debugging your services? And yeah, so I think those are the components that we'll cover. I think an interesting interplay between some of the technology we'll use in these sessions is the service mesh and the API gateway, right? Because that is something that often comes up. Do you need one if you have the other, or do they overlap? there's these things that come up in that space.
And I got some questions for you about API Gateway, but maybe
Yeah.
maybe we should show these good folks some like.
Okay. Yeah. So let me know what you all can see. So okay, are we on the console right now? Okay.
Yep, we're all good.
So from the console, the first thing we're going to show is our environment. Okay, so we're running on a Kubernetes cluster. Actually, maybe the first thing we should show is the link or the guide for the workshop that we published that we will be basically following through for these different episodes, right? So we have kubecon.demo.js. If you go there under the getting started section, right, we have the minimum requirements to run through this material. So if you're going to run it locally and you want an environment spun up for you that has all of the prerequisites, we have that option in the guide. The second option is you have your own Kubernetes, you have the tools installed that you need, and as you go through, you'll see which ones we need. And you're going to run it on your own environment, and that's fine too. The guide will help with that. There's an interesting tool that we're using here, developed by Nick and the folks at Hashi, called Shipyard, which will help automate bootstrapping a fully prepared environment for you. We also used Instruct also, right? We use Instruct on kind of a web delivery platform where everything's all set up for you. You can just go use the tooling directly from the web. But so, the example code for this tutorial is on Git. So one of the first steps is to clone the Git repo, the Consul Service Mesh for Developers repo from HashiCorp repo. And then if you're following along with the self-contained Bootstrap environment, you just need Docker. You just need access to a Docker host and the Shipyard tool. So if you have the Shipyard tool and you install that, you can just type yard up, or in this case, for some of the tutorials, we need a little bit more fine-tune the configuration. Follow the command line in the guide for yard up by passing in some values for console, and then that will start a Kubernetes environment for you inside Docker. It'll install some of the pieces that we'll be using, like Consul and Consul Service Mesh. And after running yard up, you'll have a fully provisioned environment. The same thing would be true on the Instruct. Oh, go ahead.
I was going to say, and we're going to be using this format, this environment, week in, week out. So week one, we're going to kind of run you through the getting started. But next week, we're going to be looking at distributed tracing inside of your application and Canary deployments and debugging in subsequent weeks. And all of that is going to follow through this environment. So please play along, and of course ask us questions offline if you are kind of playing along, aside from the live stream.
Right, exactly. So let's say we have Shipyard, we install an environment, we check whether the console UI shows up correctly, which it should on a successful launch of the environment. We can check whether the Kubernetes dashboard came up, and that should as well. Now, Shipyard also has an excellent way of following along in an IDE that has everything already curated for you. So if you run Shipyard VS Code, it will basically download a VS Code running in a Docker container and give you the IDE in a web browser, right? And it will be connected to Consul and Kubernetes, and from the web browser using the Shipyard tool, you can run through the material just as you would from your own machine on a terminal and connected to Kubernetes and so on. So we've tried to simplify the experience of bootstrapping the environment, getting everything set for you, so that you don't have to go out and try to scavenge yourself for all the individual tools and versions and so on. So you should be able to run this material directly from a web browser. So if we go past that, we install a demo application. So if we come over here, actually, I already have it installed. Let me just delete it. So if you followed along so far, and we have the environment bootstrapped, we're able to reach the various components. Maybe you're going to use the web VS Code, but we should get to, if you can see the terminal, we should get to a point where we have the prerequisites installed and running successfully. And we see that here. We see the console servers, we see the console agent, we see the Consul Connect, or the service mesh injector. And so what that means is when we deploy a new application, this webhook injector will find that we installed a new application and automatically inject the components necessary for that application to participate in the service mesh.
So just kind of very, very quickly, Christian, like, explain to me this whole service mesh, just from a communication perspective, because I'm interested to know, why wouldn't I just, like, why do I send traffic over the service mesh? Why am I not just kind of sending traffic, direct between my applications? What's the kind of the sort of the deal on those sort of things?
Yeah, no, that's an excellent question. And let's start off with the simplest answer, which is yes, you can send traffic directly to your application, to the other applications, to the services, right? But then, as we started to establish earlier in the discussion, that in a cloud environment where things could be failing, coming and going, you could be scaling up, scaling down, connections can be severed, connections, messages and packets and requests can be, it might look like it's getting to the service, so you're still sending stuff, but it's not, right? So there's all of these failure modes that crop up when we start sending messages across the network that we need to solve for. So the application has to be smart enough to say, all right, I need timeouts. I need to retry on certain failures. I need that if I'm hitting a service and it's slow, or if it's returning me errors, then I need to open up the circuit, so to speak. And let's stop calling that one, right? Because we don't want to. We want to be in control over the failure domains and how we respond to those failures, right? So you need timeouts and retries and circuit breaking. You're going to need some sort of client awareness of what's happening in the topology and the services that you're talking around you. You need some way of collecting telemetry about what's happening around you on the network, and so on, right? And in the past, we would write these as application-specific libraries or frameworks, and we would just kind of bundle them into our source code. And this it was necessary. We had to do it. Can't just will these problems away. But the challenge with that is each application language and framework had their own way of implementing this type of stuff. All right, and then at runtime, when you try to operate an environment where you have Java, which might be Spring and Java EE and Vertex and all these different frameworks, right? And each one of them implemented these application networking functionalities a little bit differently. And then you have Golang or Python or Perl, or it becomes very difficult to have libraries across all the languages that are implemented exactly the same. And when you find bugs and changes and stuff that you want to make in one of the libraries, you gotta have to do it for the rest of them. And because things are so tightly part of the application code, that across multiple languages, multiple frameworks becomes pretty operationally complex way of running services.
I had a problem when I first started building microservice systems, probably going on 5 years, maybe 6 years back. I found that Hystrix is Hystrix in Java. What the implementation is in Golang or in Ruby or something like that is a world of difference. The patterns which you think are the same across these different languages very, very different. So I think it's a really good point. I do like the fact that as a developer, I'm decentralizing that information, decentralizing that code and that logic, so that the entire of the team, whether we're polyglot or not, is on the same page by how these patterns function.
Exactly. It's very difficult to reason about an already complex system when you can't count on the behaviors, some foundational behaviors being consistent or running the same way. So the service mesh kind of tries to solve that problem by saying, hey, run a little agent or a proxy next to each one of your application instances. And that little proxy will implement timeouts, retries, circuit breaking, client-side load balancing, service discovery, telemetry observability, distributed tracing, security, and so on and on, right? So these networking focused pieces of functionality, if we could just implement them in one spot consistently across any language, across any framework, then we can start to reason about our distributed system with more, we're more confident in it at least. So the service, that is the purpose of the service mesh in general. And you can start to see from a developer's perspective how, you can't just, obviate the need to worry about this stuff as a developer. You have to solve it somehow. Now then the question becomes, can you simplify your code? Does it have to be in your code that you write, right? You're supposed to be focusing on the business logic and the differentiating logic, right?
So
can you separate that stuff out? And that's where the service mesh starts to help the developer.
I don't remember from where, but I remember reading, because obviously when microservices, one of the kind of key mantras is trying to reduce dependencies between microservices which cause chained deployments. So you don't want an application sort of library in one version of your service. If you upgrade that library, you shouldn't have to deploy two different services to be able to do that. You should be able to do this sort of independent and this backward compatibility. And I remember reading somewhere, and I think it was a quote from Netflix, where they took this very, 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 very seriously, with the exception to Hystrix. And I think I remember reading somewhere that within the Netflix stack of microservices, kind of this Hystrix library, which managed the reliability patterns, was the exception to the kind of the rule of this shared dependency. And I think there's another good reason to be looking at the mesh. And I think also looking at I'm really excited to hear about sort of Netflix's evolution around their thinking of the patterns. But I know that Hystrix is something which is slowly being deprecated in that environment as they move on to these more modern patterns and practices of using the sort of the decentralized reliability with service mesh.
Yep, exactly. So something like Consul service mesh starts to bring these pieces of functionality that you need to solve one way or the other. If you write it in your code, then you deal with the operational complexity of that. You can put it into a centralized gateway, and I think that's a good stepping stone to get people moving in this direction. But then at larger scale, with more point-to-point connections and so on, you might optimize for the full-blown service mesh where you have proxies deployed alongside each application instance, and those applications talk outbound to the network through the proxy, and then anything that comes into the application also passes through that proxy, and then we can apply that network control at that point. So if we look here in the console, we can see we have our service mesh deployed. So we have the control plane part of the service mesh deployed. We have Vault to store our secrets, which can then be used in the service mesh for securing transmission and so on, and we can cover that. But the first thing I'm going to do is, following the guide, is apply the sample application that comes with this workshop. We're going to apply that, and that will create a set of instructive microservices. So if we take a look here, we should see that that our services have now been deployed. And the one thing that stands out is that now when we run these services, we have a couple more containers running in the pods in these different instances. So in a typical on Kubernetes service mesh implementation, we see that your application instance starts up, and then the proxy for the data plane starts up next to it. Right, so you'll have at least two containers running in this pod. I believe in the Consul service mesh, there's a third one that handles talking with the console registry for registering the services. Is that correct? Yeah. Yeah. So the main reason for having a pod specific proxy, or a little more generically an instance specific proxy, is that the proxy then it shares the same identity as the application, and it can do things on behalf of the application. A shared gateway absolutely is a valid approach, and maybe we can talk a little bit more in a second about what are some of the trade-offs. But in a shared gateway approach, you now have another hop to the gateway that not only adds another hop, but now you can't say with certainty. So for example, if you're going to do a mutual TLS workflow between service A and service B, and you have the proxies deployed with service A and the proxy deployed with service B, you can originate the TLS connection from service A, knowing that that is service A, right? And terminate it on service B, and service B will know that it's service A that it's talking to based on the certificates and so on, right? If you put a middleman in the way, now you have to authenticate to the middle proxy, and then the proxy will represent that it's talking, that it is service A when it talks to service B, but it's not, right? And getting that identity to propagate correctly becomes a little bit more challenging. But I mean, that's for one use case. But you could also say, hey, this proxy does add overhead, and it does. This consumes more CPU, more memory, whatever, than I'm willing to pay right now. I just have a simple deployment. Why do I need all this extra stuff? Especially if you're running on GKE or Amazon or something, and CPU actually costs you per minute, right? Yep.
But
you got something to say?
yeah, I mean, like TLS. I mean, MTLS for identity is great, and that's awesome. But baseline on MTLS is TLS. So the service mesh is giving me TLS for free between my services. So I'm satisfying one of the kind of the core principles of OWASP as well in there by
That's
doing
correct.
encryption and transit. So
Yep.
like maybe you could argue that, okay, there is going to be an overhead, but it's worthwhile from a sort of a security perspective.
Absolutely, absolutely. So I do get that question about the overhead, and the point that I try to make is you have to implement this stuff somehow. Even I had a slide at some point where I showed if you did this in Java and you pulled in Hystrix and Ribbon and the Eureka specific client and Jaeger and Spring Cloud, this and that, whatever, right? You end up with a sizable amount of on disk overhead, but then at runtime, right? Maybe Java is not the right because Java Java, when it takes those classes and loads them, and it kind of expands and uses a lot more memory and so on. That there absolutely is overhead in you do this in your application or you do this outside of your application, right? So there's going to be overhead to some degree, however you do this, but you have to do it somehow. There's no getting, you can't just ignore it, right? You can put it into a gateway to start off with. So that's what I was about to say. If you have, maybe a less sophisticated or not a highly deployed set of services, or you're on Amazon or GKE where a core to run a proxy for an additional proxy for each application becomes, to start off with, not worth it, then switch to a gateway that can then help you get that, solve some of these issues for you. So I guess coming back now to our demo app, we have our applications deployed. We have the service mesh injecting the sidecar proxies, the data plane proxies into the application. Now we need a way to be able to call into our cluster and into the mesh. And to do that, what we're going to do is we're going to install an API gateway that plugs into the service mesh. The one we're going to use today is called Gloo, GLOO. It's an open source project, Apache license from solo.io, and is built on the same technology that a lot of the different service mesh implementations are built on. So it uses Envoy proxy under the covers, and it has a nice usable API for configuring API level ingress, routing, transformations, rate limiting, security, sometimes custom security, and so forth. And what we're going to see in the demo as we move forward and through some of the next tutorials is how this gateway with the mesh can be used for debugging purposes, right? So that's going to be one of the big use cases that we see in using this gateway.
So as a tool, it's obviously an incredibly useful thing on its own, but also it leverages it allows us to do a lot of the things that we're going to show later on. Question, Christian, like I know you're going to kind of dig into this, but just something to maybe I'd like you to try and explain to me as you're going along. But is a gateway an ops tool, or can I as a developer leverage this gateway? Can you show me like those kind of things, because I'm interested in that. I want that fast workflow, right? I want to be able to take my own responsibility.
Yeah, no, that's a great question, and I think traditionally these gateways, so this type of infrastructure, has been positioned as an operational. Let's get a centralized group together, just like with the enterprise service bus. Let's get an API management in place, and we'll have this one group operating the API infrastructure, and whenever you need to make changes to it, you go file tickets with this group, and because they have to own it because of security or whatever. I think what we're seeing with these newer next generation gateways like Gloo is the workflow is more important than the technology itself, right? So how we get people to successfully use this and use it in a self-serve kind of mode that's where we need to be, right? So with something like Gloo, what we can do is we can install the gateway and kind of separate out the duties of the various personas that would be interested in using this. So absolutely, there's still operational ops folks concerns, right? They're concerned about the various protocols that we're going to expose, the various ports, the security that we want to enforce, maybe rate limiting, this type of stuff. But the developers, they probably want to influence how routing works. What are the context paths? What are some of the transformations that we might use? Maybe we're going to expose things as a RESTful service, but internally we want to use gRPC. So how can the developers take ownership of that and have that be part of their workflow? And so Gloo has its API built specifically to support that kind of use case. So if you if you have the web browser around, Nick, if you could go to the Glue documentation, there is a section in the Glue documentation on what we're calling the routing table delegation, or route delegation, where we're separating out the responsibility and the ownership of the routing that a service has. So when traffic comes into the cluster, how does it get to your service, versus the operational responsibilities of, well, this needs to be TLS, and this needs to use these certificates, and we need to manage the certificates a certain way and rotate them or whatever like that. There's absolutely operational concerns there, but we're able to delegate out to the teams that are willing and able to consume this, the part of the API that applies to them. And I think that's a powerful enabler of this DevOps style, or you build it, you run it, you own it style workflow.
Nice.
Okay, so coming back, since this is the intro tutorial part, we're setting up some of the infrastructure, we're going through some of the components, why we need them, how they work together, and so on. Next thing we're going to do is install the Gloo API Gateway. And if we cross our fingers, CRDs, did they not get in there?
Oh, the CRD is applying before the.
Let's give it a second. Let's see what happens. Right. So basically, what we're doing is we're installing the Gloo Ingress Gateway, or API Gateway, and the gateway is built on Envoy, right? So that we should see an Envoy proxy, and that should be the gateway proxy that we see listed here. And this might take a second, actually, because I'm on a fresh Kubernetes locally, and so Docker might be downloading these individual images. But so we should see the proxy, and then we're going to see a control plane for operating the proxy, and maybe we'll see some errors. Let's just give that a second to come up. And a question that I often get is, how does a API gateway fit in with a service mesh? And the answer to that can be confusing, because you look at them and you say, I need to do load balancing. All right, well, they both do load balancing. I need to do distributed tracing. Well, they both seem to be able to do that. Rate limiting. And so you run through these different features that you might need for your architecture, but it's not clear when you might use one or the other. And the answer that I try to give is, for your traffic where you're communicating from service to service, where you're expected to kind of know the services, right? They're communicating, the term people use in the data center is east-west, right? Your service to service, point-to-point communication. That kind of stuff, service mesh will solve, load balancing, rate limiting, and timeouts, retries, circuit breaking, all that stuff for that type of traffic. So once you start to cross a boundary, go ahead.
I was going to say, so for developers, I mean, some folks who may be kind of new to the sort of the microservice patterns and practices, the kind of the concept where, when I was kind of learning this stuff pre-service mesh, one of the kind of the core things was you would do client-side load balancing potentially. You had to write that application logic into your code, and the same with like the circuit breaking. And okay, yeah, we lose libraries like, well, not Hystrix. I was a Go programmer, but I like the fact that this becomes configuration rather than code. That's that's a good thing for me, right?
Right, exactly. Because like we've said, that the implementation of this type of stuff doesn't need to live in your application code. It's, if you're just able to configure it, you might still be responsible for the configurations of it, but it runs outside of your application and doesn't matter what language or framework you end up using. You just use a configuration to drive the behavior of the tools, which means you can also change that configuration at runtime and so on. Yep. So it looks like we're having a little trouble here with this.
Well, we're actually running up on time, and I'm wondering, maybe I think it's been really important to discuss the sort of the fundamentals, and I hope people have found it useful. As I say, we always intended that this series is going to be a series. It's not a one-off. We have a lot of information to cover, and it's not something you can do justice within the sort of the 40 minutes that we have allotted. So maybe for this session, what we do is we're kind of going to drop things there, and in the next week, same time, same show, we will pick things up, and we're going to start to actually get you up and running with that API gateway. And if folks are interested, the links we put in the chat, also it gives you the opportunity to maybe have a look through, play around with yourself, and most importantly, please ping us, because we want to answer you the questions. We're not here to sell you anything. We are here to try and share some of our information. That's kind of the core principle that we want to do these four live streams. So please, I'm Sheriff Jackson on Twitter. You're Christian. You've got to not just
Christian Post
on Twitter.
Yeah, just at Christian Post on Twitter. Yep.
Of course, the YouTube chat. I don't know whether the YouTube chat stays live after the event or not. We will see, but please reach out to us, because we want your questions, and we want your questions so in the next show as well we can also answer some of those questions.
Yes, absolutely. We would like this to be as interactive as we can, and you can help drive some of the way we take the content that we have here.
I watch a lot of YouTube. I'm a big fan of fighting games, and also watching like people restore cars and stuff like that. I've got no interest in mechanics. Do we need to do like the like and subscribe? How do you do it? Is it like, where's my finger? Is it like and subscribe or?
Yeah.
I'm a total novice to this. How do you do that?
Maybe right here. There we go.
Yeah. I really want to thank you all for joining us today. We're really looking forward to episode 2. Episode 2, that's when we start getting into the meat of things. We're going to start really digging into the code. All of the materials, as I say, they're available for you. The links are in the chat. Please take a look. We'll put the links as well in the description of the videos. And we want your feedback. We want to help you with your problems. So if there's anything we haven't covered, please ask. Nothing would be more pleasure, I think.
Yeah. So again, thanks for joining. Thank you, Nick. This has been a pleasure, and we'll pick it up next week.
It's always a pleasure to talk to you, buddy.
All right. Cheers.
Till next time, next week. Bye.